order of an element definitions. So if you have a group, G comma star, and let's assume A belongs to G. If A is identity element, then what is order of A? Means what is order of E? That will be 1. There is nothing to check here. Identity element order will be 1. Now, if A is not equal to E, then what will happen? Then I can say order of A is same as subgroup generated by A. Size of subgroup generated by A, right? This is definition number 1. And what is another definition? Another definition is order of A is smallest positive n. Smallest positive n such that A power n is equal to E. Okay. These two definitions are same. So you can apply this definition or you can apply this definition. Both are same. So all these three things are same. So this means order of A. This is same as how, okay, what is the size of subgroup generated by A? Size of subgroup generated by A. And this is same as smallest positive n such that A power n is equal to identity element. So these two definitions, are they clear? See, these are very simple, just two definitions. Okay, I just wanted to tell you how they are related with each other. Okay, so if you did not understand how they are related to each other, don't worry about it. These two definitions you have, you can use any of them. So there are two definitions for order of an element, and how they are related, why they are related to each other, this is what I told you. Okay, so this is not a hard thing. Okay, so this is the idea. So you can just take this note, you can take, if you want, you can take this note. So if order of A equal to n, then what can you say about A inverse? Then A inverse is what? A inverse is A power n minus 1. Yes or no? So that is the idea. So if order of A is n, what it simply means, you already know what it means. It means A power n is equal to E, where this n is the smallest, positive integer. Okay, so that this is equal to E. Now, because A power n is equal to E, so I can say A inverse will be A power n minus 1. So this is the idea. Okay, so just like, so you do not have to worry how they are linked, why these two definitions are they are, you know, one definition is related to another definition. These two definitions are related with each other. Okay, so that is the reason. This is what I told you. Okay, let's move on. So order of an element, this is the definition. Order of an element means I can say order of element is the smallest positive integer such that you will get. And but sometimes what will happen, see, if you have an infinite group, then sometimes what will happen, see this, for example, consider this group, set of integers comma addition. Now tell me what is order of, if in this group, if I ask you to find order of 2, then tell me, should you only go in the positive direction? Should you only go in the positive direction? Should you only go in the positive direction? No, because if you keep going in the positive direction, then you will not find identity element. Yes or no? Are you getting my point? So take care when you have infinite group. So when you have infinite group, then just take care. In case of infinite group, I can say, in case of infinite group, what I can say, if you go in the positive direction, if you keep going in the positive direction, then you will never get identity element. Basically, you will never get identity element. I told you what I told you. I told you, if you get identity element, then you don't have to go in the negative direction. If you get identity element, then you don't have to go further. You don't have to go in the negative direction if you get identity element. But if you don't get identity element, then you have to do. Then just apply the definition. So 2 power 0 is identity element. 2 power minus 1 is minus 2, 2 power minus 2 is minus 4, and so on. So what that will be? That will be your 2z. Yes or no? So this note you can take. This note you can take. So tell me, what is order of 2? Anyone want to tell me what is order of 2 here? How many elements 2 can generate? Order of 2 means how many elements 2 can generate. That is infinite. What is the smallest positive integer such that 2 power n is? Tell me what is the smallest. Tell me what is the smallest positive. What is the smallest positive n such that 2 power n is equal to 0? So there is no such n, right? There is no such n. There is no such n. So we say that. So what we say that the order of 2 is infinite. So this is the note. Okay. First note, let me tell you that if there is no such n, there is no positive integer. If there is no positive integer n such that a power n is equal to e, then what we will say? Then we will say, this is what we will say. Then we will say that order of a is infinite. Order of a is infinite. This is what we will say. Means a has generated infinite number of elements. Okay, it simply means that a has generated infinite number of elements. So a, okay, I can say a can generate infinite number of elements. This is the idea. A can generate infinite number of elements. Okay, so this is the first note. What is the second note? The second note that if you get, so let's assume if a power n is equal to e, okay, and where n is a positive integer, where n is positive integer, or I can say smallest positive integer, where n is smallest positive integer, then in that case what will happen? Where n is smallest positive integer, then in this situation you don't have to go in the reverse direction. If you have a power n is equal to e such that e is the small, this n is the smallest positive integer, if this happens, means if you are getting identity element by some positive integer, okay, smallest positive integer, then what you can say? Then you can say that, okay, then this will be the subgroup generated by a. So you can start from a power 1, a power 2, a power 3. This will be the subgroup generated by, okay, because this is your identity element. That's it. Is this clear? Is this point clear? Tell me. So if you can generate identity element, then you don't have to go in the negative direction. This is okay, and you don't have to worry about a power 0. Why you don't have to worry about a power 0? Because this identity, a power 0 is identity element, and this is what you have. So you don't have to worry about a power 0. So I can say this is your a power 0, and you don't have to worry about a inverse. You don't have to worry about a inverse. Why? Because what is your a inverse? This is your a inverse. So you don't have to worry about a inverse. This is your a inverse. So very simple. So if you can generate e, smallest positive integer such that you can generate e, then I can say that then the subgroup generated by a, that will be a power 1 to a power n. That's it. You don't have to go in the negative direction. You don't have to worry about a power 0. This will be your a power 0, and this will be your a power minus 1. Means this will be your a inverse. Okay. And the third note, for infinite groups, what can happen? For infinite groups, take care. Take care. So if for infinite groups, what you do? Just take care. Basically, first you find whether you can generate identity element or not. Okay, by some positive power. So for infinite groups, I can say the order of element can be infinite. I can say. Okay. So for infinite group, you just take this. This is what you take. A power integer. Just apply the definition. Very simple. Nothing else. Just apply the definition. You will get your answer. And what is order of n? That you already know. That will be the smallest n. Okay, smallest positive n. So just apply the definition. If there is no such n, then the answer will be infinite. The order is infinite. Okay. So let's move on. So is this concept clear? So this is the question. The question is asking that the order of elements. You can just check it out. Okay, the order of elements means this is the order of 0. So this is the order of 0. This is the order of 1. This is the order of 2. This is the order of 3. This is the order of 4. Okay, like this. This is the order of 9. So tell me who are the generators? So tell me who are the generators? The order of generator is equal to, will be equal to 10. Generator means which can generate all the elements. Generator means which can generate all the elements. So you can notice 1 can generate all the elements, 3 can generate all the elements, 0, 1, 2, 3, 4, 5, 6, 7. 7 can generate all the elements, and 9 can generate all the elements. Generator are 1, 3, 7, 9. These are the generators. You can take this example, you take, for example, set of integers, comma, addition. Okay, and tell me what is the order of, for example, what is order of 0? In this order of 0, what is that? So that will be 1, right? Order of any other element. Tell me what is order of any other element? What is order of A? What is order of any other element in this particular group? In this particular group, what is order of any other element? Order of any other element, that will be infinite, because the subgroup generated by A, that will be AZ. So okay, so yes or no, in this particular group, in this group, every element has a infinite order. Every element other than identity element has order 1. Other than identity, every element has order infinite. But this will not happen always. See, this will not always happen. If you have infinite group, in infinite group, you can take this note that in infinite group, order of an element, what it will be? Order of an element can be finite or infinite. Can be finite or infinite. And what about in a finite? What will happen in a finite order, finite group? In finite group, what will happen? Because it is a finite group, so the order of any element will be finite. Order of every element will be finite. Because it is a finite group, so how many maximum you can generate? Like maximum you can generate is finite number. So order of every element is a finite.